button. Off you go then.
Okay, so this presentation is about the Centralis company network. So away we go. Who are Centralis? What we do? We are a company that offers strategic consultancy. We design and build end user computing services, product resale, managed services and support in all areas of IT, many networks, and we also offer cloud and hosting solutions.
Okay, I'm just going to stop you there. Now I feel that you've pulled that off your website. Put it in your own words. What does this company do? So if you had to sell me what your company does,
Right.
what would you say you do?
We offer support, top class consultancy to a variety of clients, specialising often in, say, products like Citrix.
Good. Yeah. Do you see that gives me a better understanding? Yeah. Again, I'd have to know what Citrix does, which I do. But do you see what I mean?
Yeah.
Okay, good. Okay, fine.
Okay. So introduction to our network.
Oh, sorry, I'm going to stop you. What do you do? Sorry, there should be a slide. What
do
do you actually do? So what's your everyday?
I'm service desk, so I will. At the moment, I'm doing a lot of farm management.
Mm-hmm.
So it's like I'll log on to, for example, Victrix, they're a company. I'll log on to their servers. I'll check everything's running. If there's any problems, report them. So that is what I do at the moment. Okay. So the purpose of us having a network, why do we need it? At Centralis, we rely on our network big time. Without it, we couldn't do any work.
Mm-hmm.
Basically, size of the office. How big is the network? It's located here in Studley Point. It's not massive in terms of size, as you can see, but it's a decent size. Different members of the team, different areas. So say you've got a service desk, consultants, sales, and office managers, so forth. So users, I just spoke about that.
Mm-hmm.
The main purpose include the hardware and software used. So we need up-to-date hardware, software, running remote access connections for example on the service desk for our clients, Citrix receivers, various office applications to get work done. Phones are important, vital, every employee has their own phone. And it's also wireless.
Okay.
Hardware. So various hardware is used on the network in order for it to work. I'm now going to talk about different hardware used. Okay, so routers are key to allow the network to work. Yes, without the routers we won't be able to, the information, packets of information won't be able to work.
Okay, simplify it. Don't get too techie on me. What's the router used for? Where does it take you?
It will take us from our network to the internet.
Thank you. That's it.
Network.
Okay. Do you see that's simplified?
Yeah.
Okay. That's all I'm after. And remember the key point of this presentation and what we did is to make sure you know for the exam what that piece of kit's used for. Okay. So just to keep it simple, and as you're saying there, you use here a good old Cisco like the rest of the world.
Yeah, no choice.
I've met Mr. Cisco before. Used to drink down the pub. I live. But yeah, okay, so it connects you to the internet.
Yes.
Okay, that's it.
Okay.
I'm assuming you've only got the one single network here and you haven't got a connection to anywhere else. It is just a single network? Yeah, fine. Okay, good.
So yeah, that's a bit more detail of how a router actually works. So I don't think I need to talk about it, do I?
Well, I want to get the impression that you know this, that you do have an understanding. Now, there are a couple of other things I'm picking straight up on there, your ADSL line and your broadband. You know, give me a bit of information. What's that about? Because again, you've got to know it for the exam.
Alright, so ADSL is basically a technology that allows the communications, and here specifically we use BT.
Mhm.
Business broadband, ADSL. That's our supplier. We rent the line off them.
Good. Fine.
So they manage it and the line, but
Yeah.
we pay.
Yeah.
I don't know if it's monthly or yearly.
And they're so they're your ISP, aren't they?
They are, yeah.
Yes. Okay. Fine.
In total, we have, excuse me, we have 2 of these routers in place. The reason for having 2 is if one was to fail, there is always a backup option.
Good.
So the business wouldn't have to just stop working.
Which is
Okay.
critical.
So obviously, but they also, routers actually relate to layer 3 of the OSI model.
And based on what we were talking about, that's the important bit. So
Yeah.
which is why you must learn that diagram that tells you all of that. It's a very simple diagram. If you learn it, it will be good.
There's an example of our router.
Lovely. It's a lovely router there. Thank you.
Beautiful, isn't it?
Beautiful.
Plus a link to it.
Yeah, yeah. Beautiful. Beautiful.
So also we have media converters.
Okay.
These basically help us get the best possible speeds for our network.
Mhm.
So with the use of a media converter, it's like 2 different types of cables
Yes.
can join together, if you like. So we have fibre cables, and to get the most out of these cables, we use a media converter.
Which just have a look what you've said.
Yes.
So it's here, isn't it? It's going from here to here in a way, isn't
Ethernet
it?
to fibre.
Ethernet,
Yes.
because as we've discussed, Ethernet is your slower.
Copper
Fibre
to
is
yeah.
copper to glass, isn't it? Yeah. So again, we were kind of talking about that, weren't we? Having your copper stars and your
Yeah, yeah.
backbones as your fibres. Yeah. Okay. And the media converter, again, a term that comes up in the exam. What would you use? It's a media converter, and the name's telling you it's converting the media.
The
Okay.
medium, yeah.
Yeah, that's another way. Quite often you'll find if I'm training you, I will convert it, I will change it round, because usually it's telling you, what it's actually there for. And I try to get you guys to do the same thing, because it makes it a lot easier.
Okay. So yeah, that's got as many advantages.
Mhm.
One of these being is it actually extends the link over a further distance.
Yes. Yes.
Another benefit is reduced chance of EMI.
Mhm.
EMI would cause a slower network, potential data corruption,
Definitely.
which would be pretty tragic.
Mhm.
It's located in layer 1 of the
Good.
OSI model, the physical layer. Again, as an example.
Yep. But again, that's showing you exactly what it's doing,
Yeah.
isn't it? Yeah.
Switches. Okay, so as explained before, switches are used to to send the packets to the right destination. So you could have 2 different network subnets, and the switch makes sure each computer gets the right source of information. Okay, so we have 4 switches in total within the Centralis network. We use a technology called dual band.
Mhm.
This technology allows 2 separate networks to be created. Basically, it's we have a wireless option, and
Yeah.
one we can connect via like an Ethernet cable.
Yeah. So you got your wired and your wireless. Yeah.
Yeah,
Okay.
and also they're 2 different band or frequency bands.
Good.
So 2.4 and 5, and you just whichever one you just. So I personally connect wirelessly. most of the
Yeah.
time,
Yeah.
so-
Yeah.
So yeah, as well, this is a backup option if one of the networks was to be faulty.
Mhm.
Yeah, switches are considered layer 2. They
Yes.
can be layer 3 as well, but these are often routers.
That's it. And for the
Yeah.
exam, watch out for that,
Yeah.
because they will call it a layer 3,
Switch, yeah.
and it's
they
not
do,
what.
don't
And then you need to look at it and go, hang on a mo, they're actually talking about a router.
Okay.
Okay, so if for the exam, I usually tell you it's switches 2, router 3, whatever else they want to call it. But yeah, you just need to be a bit careful on that one.
There's a switch.
It's lovely too.
Patch panel.
Mhm.
Pretty straightforward what a patch panel is. It's in our server room, which is just down there. It's a big panel where all different ports are connected, which link up the whole network. It's quite like the central of the network. It's where everything comes together, if you like. As I said, it's got switches connected to them. This allows permanent connection between the various computers, devices. Okay. Again, there's another example of what a patch panel looks like. Access points. These allow the wireless connectivity. So we've got quite a few of these across the office. Yes, it allows further coverage. It's quite hard often to find where a hotspot is. So you have to be careful where you place them.
Okay.
So I think we've got some in the roof.
Mm-hmm.
So like we've got some down this end of the office and up that end. So it's trying to spread it out basically.
Yeah.
Get
Now.
full coverage.
Yeah. So, which is key to your wireless network,
Yeah.
isn't it? So, the kind of question you might come across in the exam is, what would you do? So, if I was your customer and I came to you and I said, I want a
Yeah.
wireless network, what would be the very first thing you do, more or less, that you would do to make sure that you had that coverage? What would you need to carry out to be able to work out where to place your access points?
Some sort of test.
It's got another name for it.
Yeah.
It's a site survey.
Right.
Okay, they're very hot
Yeah.
on that for the wireless side because of what you've just said. In the old days, there was nothing more irritating than being over there and having wireless access and walking a few steps away and going, oh, I don't have any anymore. And that's because we were very green to it when it
Right.
initially came out. But now we understand it more. We know. And they will often ask that question, what do you need to do? And it's carry out a site survey. Okay, that's what they're after. Okay, does that make sense?
Yeah.
Yeah.
So just explain this. We also have a wireless access controller,
Mhm.
which is it's just an access point, but it's a dedicated one.
Mhm.
So pretty much all things go through this, and we can check this access point to report on our traffic and how much bandwidth we're using wirelessly.
Good. Yep.
Okay. So I've explained they're in the roof. They're a layer 2 device in the OSI model. Okay, Citrix NetScaler. Okay, this is a piece of hardware that's pretty vital to Centralis, I think.
Most customers as well.
Yeah,
Mm.
yeah, it provides, we use it to provide services to our clients. It helps us manage, like, as I said, file management, so you can manage their servers. Yes, its main function is cloud-based services.
Okay.
So, like applications, so whether it be a client or an employee, we can use the NetScaler to actually, it's called Zen Mobile.
Yep.
So
Yep.
it's like a piece of software.
It's a bit like a load balancer.
Yeah.
So
Okay.
it sort of flicks between if there's too much load on the one. then
Right,
It
it
will
will-
automatically route to the,
Okay.
to
Yeah,
the
so-
next server.
So it just allows wireless use.
And the Citrix side, what are you providing there? Desktops, apps? Do you use it? Yeah.
Storefront. Yeah.
Yeah. So you're providing the whole shebang,
Yeah.
and they come to you.
Yes. Zen Mobile. Yeah.
Yeah. Okay. Fine.
Yeah, so it's expanding Zen Mobile. It just allows employees and clients to access applications anytime.
Mhm.
It also saves a lot of work as well because you can set up virtual servers and so forth. So, yeah. And that is what the NetScaler looks like.
Mhm.
It's services and software. It's Microsoft Office basics, PowerPoint, Excel, Publisher, Word. Everyone uses it in the office, everyday tasks. The specific package we use is Office 2016. Outlook is the email as well we will use. I don't know if other employees use different emails, but I use Outlook. It's a useful tool because we have all our service support in one area.
Do you? Is it full blown Outlook, cloud based, or Exchange based? Do you have Exchange here?
Exchange. Yeah. we don't use Lotus Notes either. So.
No. But do you have an actual Exchange server on site?
Yes.
Yes, you're unusual.
Well, we need to obviously be in the cloud business. We
Yeah.
need to touch that.
But yeah, good. Okay, fine.
VMware. is a piece of software which allows employees to create their own virtual machines.
Mhm.
Employees, it varies what they use these servers for. I know some do like work on like test servers
Yes.
for clients, practicing before they put stuff into practice.
Good.
I know you can also use it for storage of apps,
Mhm.
so forth. Yeah, that's the main use of VMware. So it's quite a handy method. It also saves money as well because
Okay.
you haven't got to keep installing server after server.
Yeah, exactly.
Okay.
Okay, so Microsoft's equivalent, do you know what that is? It's Hyper-V. So
Right.
we will be using Hyper-V for our Microsoft training. So when we do that, I will ask you to have a 2012 virtual box, and most people will Hyper-V it because they can use it on the client. So, Windows 8, Windows 10, you can use Hyper-V. So you'll be
Okay.
using, and the idea behind that is to do what you've just said. It's not so much testing, but it's training. It's a really easy way that I can actually get you to install a server, install DNS, etc., etc. So
We can help you with that.
yeah,
We've
so
got Steve's got Hyper-V experience.
perfect. So so as you say, it's so more cost effective. Because if I said you all need a physical server for the next 6 to 8 months or whatever, it's not going to happen. Okay, but with a VM you can do that. Yeah. Okay.
Another service, Morncast,
Mhm.
which we use, it's an email service. Obviously it's used for emails, and it offers security features for our emails. That's pretty much it. It sends regular reports. And
So who
forth.
uses that then? Because you've mentioned Outlook. So where does Mimecast come
We
in?
basically use that as a backup.
Right.
So,
Okay. Yeah.
Anything that may not be through the Exchange server goes straight to mine.
Right. Got you. So it's an additional
Yeah.
feature or
Yeah.
service. Okay. Good.
DNS. DNS is possibly the most important service we use. It's a protocol for how computers exchange data on the internet. So what it does, say for example we have our own domain name, which is centralis.co.uk. With a DNS, it translates this domain into an IP address,
Yeah.
which computers can read.
Yes.
So without the IP address, it won't work. Computers won't be able to communicate.
Okay. So who's the name for? Why don't we just say, what's your 192.168.1.0 server all about?
So obviously domain names are for humans.
Exactly.
It makes it
Yeah.
easier.
Absolutely. And you'll set up DNS, and we'll talk DNS, because without DNS, your network,
It just won't work.
yeah, exactly, AD won't work, etc., etc. So that's very big. Not so big in the Network Plus, but you must know it's named to IP for Network Plus, and you can do reverse lookup as well. But when we come to Microsoft, we will home in on that big time.
Okay.
Okay.
So as I said, it's very important. Also here, there's a lot of virtual servers used, so they're all stored in DNS basically.
Mhm.
It's like a phone book, is the best way to put it, for the network.
Yeah, absolutely, absolutely. Here's the name. What's the number? Yeah, yeah, definitely.
Okay.
Okay.
DHCP, Dynamic Host Configuration Protocol. This is used to provide IP addresses to hosts, so IP addresses to computers and so on. I will talk about. While Centralis uses DHCP. Every device on the network needs a unique IP address, and DHCP provides them with the IP address. It saves, you don't have to do it yourself,
Mhm.
does it automatically, and it makes sure no two are the same.
Good.
So,
Less human error.
exactly. Okay, that's basically what I just said. Telephones. As I said, it's very important for Centralis.
Mhm.
How does the telephone service work? Well, we have the telephones we use are by a company called Snom. Very, as you can see, quite handy. One like that.
Very antiquated.
Say that again.
Very antiquated. They do a job.
And make phone calls. Isn't that what phones
Oh,
for?
well.
Allegedly. Not according to youngsters, eh?
No.
No, you've got to pick the phone up, my God.
Okay, so yeah, so in order for this service to work, again DHCP is used like it's with computers.
Mm-hmm.
Telephones actually have IP addresses as well.
Yeah.
They're in a different segment
Mm-hmm.
from PCs.
Yeah.
But
Why is that
again,
the case? Why have you done that?
it's to prevent. It makes it simpler. So if you're looking up your IP for your phone, they're all here. All your computers are there.
Okay, what about from the traffic point of view? Why? Because so in other
Yeah.
words, you've segmented your traffic from data and VoIP, haven't you? So why is VoIP important?
Because it's voice over internet
Yeah,
protocol. So
okay.
it's without VoIP you wouldn't be able to speak on the phone.
Okay, so why do you keep your data? Why do you keep it separate? Think about your collisions and things. Why does it make sense?
Prevents collision domains.
It does in a way, and you've got different types of
Yeah.
traffic, haven't you? This is your VoIP's probably considered to be more important in a way. Would that make sense?
Yeah.
And so what would you prioritise more, your voice or your data?
I'd say data. I don't know. For telephones, voice.
Yeah.
But if you had a network with both voice and data,
Yeah,
what would you prioritise? Would you prioritise your voice or your data?
probably voice.
Yeah, good.
Yeah. Yeah.
Thinking about it.
Yeah, and when we talk about QoS, quality of service,
That's
we
it.
always refer to VoIP and, as you say, assigning it on separate networks and then making that priority.
Right, okay.
Okay, VoIP wins the day.
Because sometimes you do get the collisions. That's when you get a bit stutter on the phone, and you can hear.
Cuts out and
Yeah.
everything. Yeah. Okay.
Not a good network to be in.
So I've also got a little bit here about SIP trunking,
Ooh, yeah.
which is a protocol. It's a VoIP technology, and it just simply allows. I haven't got much on it, to be honest,
No,
but I
that's
know
okay.
it's provided by BT.
And what does it say? It provides what? Finish off what you've written there. Allowed for what?
Provides telephone services over the network.
Okay, but look what you've put. It allows media and voice communication to be streamed
yeah.
across the network. So it's,
Yeah.
it's the allowance of that side of things, yeah? Okay.
Citrix and mobile. But it's a service provided by Citrix that allows the virtualization of apps and data. Employees have the ability to access their apps while on the
All the
move.
dice.
Yeah. So what it allows, this is more like a management side.
Yep.
So we can mobile device management. So manage what mobile access is what.
Have you got this set up on your phone yet?
No, not yet.
You can do that.
I know. I'll look into it. It'd be quite
Yeah,
handy to be fair.
because I've got it on mine. I know I've got a company one, but I set it up on a personal one because it's and you can do that, so you can check your emails over the weekend if you want.
I'll look. Yeah.
I'm joking.
Do you know I can't do that on my phone?
Yeah. Mobile app management, which is just managing the apps.
Yep.
Individual sign-on. Each user has their own sign-on,
Mhm.
username, password, shared devices. But in order for it to work, we actually have a DMZ, which is specific for Zen Mobile. It's separated from our LAN, so it's so basically the stuff that's in DMZ. They can be accessed through the internet, which is why we don't. But like the LAN is all very much private stuff
Yes.
internally.
Yes.
The DMZ is obviously you access their mobile through the internet. So
Yes. And the fact that it's mobile means warning, they're
Yeah,
coming
yeah.
in from the outside world potentially. So whenever we do that, we whack it into a DMZ. Okay, most definitely. Okay.
Okay. So that's the interface.
Okay. Angry birds.
That's not my interface. So, okay, network diagram. So I've now spoke about the components that make up the network.
Okay, so let's
I've
have a
now
look at that
got
diagram.
a diagram. Okay, right. So if I just talk about each section, so we start with the LAN. This is all the physical machines, printers, so forth. But I think the virtual machines are in the LAN as well. If we move up, I've spoken about the Zen Mobile DMZ.
Yep, okay, got the Zen
We've
Mobile.
got another one here, which as far as I'm aware, actually no, this is where the virtual servers are based,
Okay,
virtual machines. And we've got our FTP server, so
okay.
important servers are based on that.
So let's just look at the difference. This
Okay.
to me, I'm assuming your desktops,
Yeah,
yes? And then that separates your servers out, does it?
Yeah.
Okay. So similar principle, isn't it? You're protecting your servers at a slightly, to give them a bit more
And
protection.
then you've also got swivel. You know,
oh yeah. Isn't that secure? Something to do with security?
Yeah,
swivel?
two-factor authentication.
Okay.
Yeah.
Okay.
So yeah, thumbprint or
Yeah. Your eye.
I don't think we've got that far.
Okay, so if we move up, we've got the TMG,
Yep, threat management
Yeah.
gateway.
which is it helps from web-based threats. Basically, it's got quite a lot of features like firewall. It allows VPNs, virtual private networks, which is handy for intrusion prevention
Mm-hmm.
and URL filtering through to the internet, coming
Yeah.
in from the internet. As which I was going to explain, because here's our two routers
Mm-hmm.
up at the top. This is the BT business broadband.
Mm-hmm.
There's a lease line there. Two firewalls.
Mm-hmm.
And there's our firewall DMZ and our NetScaler,
Mm-hmm.
as I've spoke about.
Okay.
Okay. That's my fault. IP addresses. What are IP addresses? They're how one computer can communicate with another computer through the internet.
I'm just
Yes.
so the thing that all of them do is relate to the internet. I'm finding it quite hard. Relate it to your internal network because you have IP addresses
Okay.
internally, don't you?
Yeah.
So I'm saying this to all of you because it's natural for you to do it because your understanding is the internet, okay? But if we chop that internet off, we'd still need what you're going to talk about.
Yeah.
So, and the reason I'm saying that is in the exam they won't talk about internet. It will be all internal and they'll talk about internal subnets and networks. You've just got to make sure you can picture it.
Okay.
Yeah, so just think
Right.
about that because that's what they're talking about. It's a networking, not internet working, as it were, or the internet.
In that
Okay.
case, then they'd allow communication over the network. So
That's it.
each
That's it.
like we'll have me and Dave with different IP addresses
Mhm.
type thing,
Yeah,
and
good.
that's how they communicate.
That's it.
Okay.
Does that make it simpler for you?
Yeah.
Can you put it into
Yeah,
context then? Yeah.
I suppose it's hard. I can relate to this because it's difficult when you've got a textbook. You're going through that
Oh,
textbook and they're trying to put it into.
Totally, absolutely,
Yeah.
absolutely.
So we've got two types of IP addresses: the dynamic IP addresses and your static IP addresses. The dynamic are temporary. Yeah, and they are assigned each time a computer accesses the internet.
Okay, bring that into what did you say earlier on? What was the service that we use internally?
DHCP.
Good. So DHCP dynamically assigns the IP addresses
Right.
to our client
Yeah,
machines.
yeah.
Okay. So tell me now what the static ones are, and give me an example internally when you'd have a static address. One that must never change.
I don't know.
Okay, so think about what.
Server.
Yes, good.
Server.
Well done.
Hmm.
Yeah. Anything I was going to say. Anything
Yeah.
that's critical. I think
Right.
that's mine buzzing.
Oh,
Don't worry, I'm going to ignore it.
So static IPs preferably used for services like VoIP, for
Yes,
example.
most of. Yep.
Okay. They're very easy to locate. How? Yeah.
So any of your
I'm not that
servers,
sure.
that's okay. So any of your servers, anything that's critical, DHCP, DNS, domain controllers, your
Yeah.
routers, your switches, anything that must remain static, we would manually configure. So you would go and put in the IP address. But because the clients, that it's not that important, because actually we use names more to communicate. As long as a client has an IP address, we don't really care what it is. But with your servers, because we might need to connect using IP, they've got to remain static.
Got it.
That's where that is.
So IP addresses on our network. there are a lot of IP addresses used because, as I've said, there's quite a lot of virtual servers and devices and so forth. I'm not going to list every IP address. So we use a private addressing scheme
Good.
using this IP address 192.168 through to 192.168.255.255.
Okay.
On the internal LAN, we use the 10.0.0.0 private
Yeah,
addressing scheme
Okay.
to keep it as private. Having these private addresses means any connection from internet or outside networks can't be routed in.
Exactly. So
So
it's
it
another layer of
saves-
security,
yeah,
isn't it? Okay, now I'm just going to ask you some questions on that. If I said to you, could you tell me what... actually, okay, have you got a screenshot of a network card with IP address, subnet mask, etc. on it before I ask the question?
Not my network card.
Okay, so what I want to know is, if I said to you, what does an IP address represent? We talk about it representing two things. Can you remember what I taught you with regards to streets and houses, how we relate it back to IT?
One's address. No, it's address book, isn't it?
Yeah, so take your street. Remember we went through Mr. Postman standing at the crossroads and he needs to know which way to turn, left or right. He's going to use the street address, isn't he? Okay, so we relay that as our network address. So if we were looking at this is what your network address would be.
Right, yeah, I remember
Okay.
now.
Have you got anything with your subnet mask on?
Yeah, it's coming up.
Okay, perfect. All right, that's fine. Okay, that's what I wanted to know.
There you go. A default subnet mask will also be given for all
Okay.
these ranges.
Have you got the default?
Yeah.
Yeah, good. Okay, that's okay.
The previous image I've just shown, this is it
Yeah.
now with the IP addresses on.
Okay, that's fine. So that's your
So
physical or logical diagram, would we say?
this is now the logical, yeah.
Okay, good. Yeah, that's fine on it.
Okay.
Although I don't think we do really, do we? But the exam does.
Yeah.
We just go, that's a very nice diagram.
Yeah.
It has everything we need on it.
So,
Okay, that's fine.
As you can see, like, there's the address ranges I spoke
Okay.
about. These NSIPs, these are used to access, I think they're mobile phones actually.
Okay.
That's for our phone service.
Okay, so if we looked at this, 192.168.10.0, and then we had to look, we've got 255.255.255.0 mask. If I said to you which of these octets represented the network address, would you be able to tell me?
First two, isn't it? First one.
No,
No,
it's
I don't.
okay. So I'm going to write it how it would look. What 10.0? Okay. So if I said to you, it's wherever there's a number in the mask greater than 0, that represents your network address. Okay, because they're not your defaults as such. Well, they are. That is a default actually because it's a class C. Okay, but what we have to, and I will teach you guys this again and probably again to make sure, in the exam you would see this written differently. You would see it as a /24,
Right.
okay, which would equate to the number of bits being used in the network address. Okay, now there's a critical bit of information that we have to know. How many bits are there in an IPv4 address? So how many bits are there? Can you remember off the top? So
32.
perfect. Okay, so if you know that magic number's 32 and they've put a /24 in it, yeah?
It'll be the first three octets.
Yes, perfect. Okay, but that's too easy. So what they might do, I'm afraid, is put a /27 in it. Okay, so it's still the same because it's saying how many bits are being used for network. It's whatever that number is after that slash. Does that make sense?
Yeah.
So if you just remember, whatever comes after that slash is saying network bits. Okay, and then we take it one step further. We say how many host bits are there? Well, you simply take 27 from 32 and that will leave you the number of host bits. Okay, now as I say, we have been through it. We have to go through it.
It's hard though.
Oh,
It's tough, yeah.
It is tough because guess what? You wouldn't do it in the real world. You'd get somebody else to do it, or go and get a calculator. You just
Well,
won't
yeah,
do it. So, but which is why it will be the last thing I teach you again when we do our revision. I'll do a session on it, and we'll just keep hammering it. But that's the first thing to know. What is it coming after that? Is your network bits, okay?
You can use Stuart as well. He's good at stuff like this.
Yeah.
So, yeah.
Okay. Okay. Good.
Right then. Still talking of IP addresses.
Mhm.
This is just looking into more detail really
Okay.
on ours. So. Oh yeah. So this is the internal LAN. These
Yep.
are some IPs that
Yeah.
that are based in the internal LAN. So this is an employee's actual IP addresses that they use.
Okay. Okay.
So. Just an example.
Yeah. No,
That's just one employee's IPs.
Mhm.
Another example is the phone system. As you can see, the IP address, and it's all in the same range.
Okay.
It's all static, which
Yeah.
is VoIP,
Yeah.
and you can see the locations, the
So-
description.
With the phone, you
Yeah.
can't have the IP address changing, I would imagine,
No.
because otherwise somebody, that's what's used to tie the phone, for the communication. So it has to be the same every time. So
Yeah.
that's why it's statically configured.
That's it.
Okay.
Okay.
It looks like there's servers on there, are they?
Mm.
There we go.
That's-
Yeah, because this is the TMG. So
Mhm.
these are the IPs that reside at that level, basically.
Okay, that's fine.
So as you can see, it's yeah.
Okay. Yeah. No, that's
Mm.
fine. That's fine. It's really to make sure you understand. So that's good.
Missed a slide.
Yep, that's it.
Oh yeah, this is my personal machine. Just
Okay,
yeah,
so it's just showing that
Yeah,
you're
so
on that network.
there's more
your
IP4.
10.0 network.
my
Yeah.
address, my subnet mask,
Mhm.
domain.
Mhm.
That should come up first. Yeah. Default gateways. What is a default gateway? Default gateway is a bit like the access point, where a computer can send information, receive information. It's called default because it's set automatically, but you can configure it.
Okay,
So
I'm going to simplify this even more for you.
okay.
Microsoft call it a default gateway. What do the rest of the world call it? It's your router.
Yeah.
Yeah. Okay. So
Mm.
I wish they would just call it a router. In your book, in Network Plus, it's very much the router. Okay. Does that make it simpler to understand that?
Yeah.
Because otherwise we think there's another piece of kit out there. But when we're talking from the exam point of view, that you're thinking, well, what's this default gateway malarkey? It's simply the router. Okay. So Microsoft, and when you configure your network card, because you're on a Microsoft OS, you'll see it as default gateway, but it is actually your router. Yeah, that's just another name for it. And if you don't realise that, as I say, people think, well, what's this other piece of kit? No, it's just really Microsoft doing their usual, confusing us all. Yeah, does that make sense? Yeah.
So
Okay.
I've actually got something like that. Well, it does perform router-like tasks. It doesn't
Yeah.
have to be a router. So it can be any computer device, but it has to be connected to the internal net, subnet, and the internet.
Yeah, so like at home, you
Yeah.
might have a machine that's doing it, right? In the old days, internet connection sharing.
Mm.
Yeah, in a way, that would be your gateway out, wouldn't it? In a way, yeah.
But like you say, it's mainly routers.
It is mainly
Yeah.
routers, and we've moved on from the way we used to. But yeah, absolutely, it's a way to get out the door, isn't it? And also, just remember, DHCP does that as well, doesn't it? Allocates IP address, subnet mask, default gateway, and DNS.
Yeah.
So anything you need to configure your host, you get good old DHCP to do
Right.
it for you. Okay.
Yeah, so this is our default gateway, from my understanding. It's located at the TMG.
Mhm.
Yes, it allows transmission to. I don't know what it's doing now. it's allowing transmission to and from the internet.
Mm.
As you can see, it's connected directly to it.
And there are lots of lovely rules on that, aren't there?
Mm.
So it also has its own firewall settings, intrusion prevention. I've mentioned
Yep.
URL filtering
Good.
for the incoming traffic. This image now will show how the network settings it's just proof. That's the default gateway.
Right, I see. Okay,
Okay.
good. Okay, so for the exam, recognise, as this is showing you, that the default gateway is on the same network address as your host,
Yeah.
okay? They're quite likely to show you something, a bit of a screenshot like this, where they've stuck the default gateway on a different network, and then they'll say, what's wrong? Okay, what do you need to alter? And it's quite often that they've assigned the wrong default gateway to the network where the host is sat. Okay, so as long as you remember, your host and your default gateway must be on the same network. Does that make sense? Otherwise it won't know how to get out and do what it needs to do.
So finally then, the DNS IP address system. So yeah, I've said before, it's a lot like DNS is a lot like a phone book
Yeah.
to the internet. Within a DNS, you have a directory of domain names. So a domain name is specific to their specific. Okay. Domain names are useless though without IP addresses. They need to have an IP address assigned to them. So the DNS actually deals with this. It translates the domains into IP.
Yeah.
So all domain names across the internet are actually gathered in one place called the central registry. And when you search on the internet, the ISP interacts with this registry, and it constantly updates information, so new websites every day. Okay, this here is how does DNS allow us to navigate the internet? So simply, you type in your web address, for example, centralis.co.uk. The ISP views the DNS associated with the domain. It reads the DNS, then it translates it into its IP address, and then the IP address is then used to direct the user to the website. So if you just look below, that there is, converted the domain into the IP.
Good. Resolve. We call it resolved.
Yeah.
We call resolving. You resolved your name and popped it into the IP. Good.
Okay. Finally, another example. So I'm now going to show the location of our actual DNS server. So DNS, they can be located anywhere on a network, but it's the ISP that provides it. In our case, BT.
Okay, but you have them internally as well.
Yeah.
Okay. Yeah.
Yeah,
Something that we'll move on to.
So as I've said when I've explained that.
Yeah. Yes, fine. So let's just see the image. Ta-da.
Right at the bottom there.
Yeah.
That's where we actually have two.
Okay, so these are internal.
Yeah, these are our internal ones.
Okay. Good.
I think
That's it.
that's.
Good. Anything to add?
No, it's pretty concise.
Is that your network?
Yes.
Yes.
Yeah, that's good.
Good. Okay.
Very good indeed.
So, tell me why you think I've got you to do all of these tasks, Jack. What's the point?
Just revising. No, not revising. Yeah, but doing that gains an understanding of how a network works.
Yes.
So a lot of that stuff I've never heard of before.
Yes.
Until I had it explained by Stuart, and just pieced it all together.
Good.
So it's kind of helped me understand new things.
Good. So, and you mentioned revising. So tasks 1, 2, 2 and 3, definitely to help you go through that massive book, because it's a big book, okay? This one, as you just said, helped you actually put it together. So if you know your network, how do you think that will help you for your customers?
I know a bit about their network, because I know the different parts of the network now.
Absolutely.
So I can know where a problem is occurring.
Absolutely. Yeah, spot on. Because if you know your own, they're all the same. I mean, I've been to see all my students now, and they've all told me all about switches, routers, etc., because they're the same. So you're absolutely right. It will help you understand your customer's network, which is always a benefit, isn't it?
Absolutely.
Okay. Good. Okay. Right. Let's